Yeah. Okay. Okay, now let's say we have a plank, a rod, a plank, or something you want to call it. Okay, now if we apply a force down here at the center, upward, this one will be pushed upward, right? Of course, obviously, right? So this one, if we apply a force, it will be pushed upward. Now, what if one end is fixed? If I fix one end, let's pick 3 points. So this is point A, this is point B, and this is point C. Now imagine that if point A is fixed, is a fixed point. Okay, I write like a triangular shape like this. This one, this fixed point, we call the pivot. Okay, pivot, or you can call it fulcrum. Remember the simple machine that we have learned, like during in our secondary school, right? Secondary school, Form 1, Form 2, Form 3, you learn about the lever simple machine, right? You have fulcrum, load, and effort, right? For example, if you want to lift up a heavy object, right, you need like this, a rod, and this is the fulcrum, this is the effort, the point where you push down, right? You apply the force to push down and to lift the object, and this is the load, something like that. Okay, so pivot is equal to fulcrum, a fixed point, right? Now if you have a force applied here, let's say 5N, pushing it up, what happened is that when the left end is fixed, this plank will tend to turn in the direction of this, the anti-clockwise direction. Okay, anti-clockwise, because the force is coming from below and is pushing upwards. So you can kind of imagine that if you fix left end and you push one end, it will like turn anti-clockwise, right? It will tend to turn anti-clockwise. But this doesn't mean that the force is turning force. It's not, the force is not turning force. The force is straight. You see the direction of the force. The direction of the force is acting upward straight, but there is a turning effect. Okay, we said that it has a turning effect. It produces a turning effect just because one end of the plank is fixed. Okay, now if I change the direction of the force, let's say I change to, okay, this is anti-clockwise, right? If I change to from the top and it's acting downward, acting at point C, okay, 4N, let's say, and this force will also create a moment, but this moment is acting in the clockwise direction. So this will turn down. It will tend to move down, right, from here. Okay, now how about if the force is acting exactly the same position at the pivot here, the pivot here. Okay, so if the force is acting at the pivot, then is there any moment? No. Okay, if the force is acting at the pivot, the fixed point, then there is no moment. There's no moment. Okay, so any point it will create a moment, but not the fixed point, not at the fixed point. Now moment can have, you can have more than one moment. Okay, you can have more than one moment. For example, if I have two forces, one acting from downward, acting on B, F1, and another force acting down here, F2. Okay, two forces means two moment. Now force 1 will create a anti-clockwise moment, correct? Now anti-clockwise moment, I label it as MA. Okay, capital M stands for moment and the sub A means anti-clockwise. Now F2, it will create a clockwise moment, so I write like this, MC. Okay, now these two moments, if I say the plank is balanced, 如果我讲这个 plank 是 balance stationary, meaning that the total moment, the moment acting in the anti-clockwise is equal to the moment acting in the clockwise direction. So we can write MA equals to MC. Remember this one. This is when the object is balanced. Okay, 就很像我们学到的那个balance forces. Okay, balance forces. So force is, if you have a balanced system, meaning that all the forces are balanced, y-axis forces, horizontal forces, all are balanced. So same with moment. If object is balanced, all the moments are balanced. Okay, now For example, the seesaw lah, we used to play in the playground, right? This one, you sit here and your brother sit here, let's say. Okay, this one, when it is balanced, right? So it will create the anti-clockwise and clockwise moment balance, right? So here it will create a moment downward. This is the clockwise moment, and here is the anti-clockwise moment. Okay, so two forces comes from the weight here acting down. Now, so when the seesaw is balanced, meaning that the MA will be equals to the MC. Okay, now this is the concept behind it. As long as you know this concept, then you can do the questions that in tree number 3. Okay, now let's look at the question. Let's look at the question. Okay, sure. Okay, now so 3. Now this one, the uniform beam has a mass of 5 kg. Okay, so 5 kg, and then you have all the forces here. Wow, you have many forces: 25, 15, 30, 20, and then you have this 3 and 2, 3T and 2T. So you are asked to find what is the tension 1 and tension 2. Okay, now first step is we want to label all the forces out. Okay, we want to label all the forces out. So let me just draw this out. This is the plank, and then okay, so this is 25, 15, and then 30, 20. Here is 3T, right? 3T square, and here is 2T. But there's one more forces. Okay, you have to take into account the weight of the beam. Okay, the weight of the beam. So 5 kg, right? 5 kg, meaning that 50 Newton. Now 50 Newton, where is it acting? 50 Newton is acting at the center of gravity, the center of mass. Okay, so if you see this plank, this one you are given distance, right? You are given distance. So you have 1 meter here, 3 meter here, 5 and 3. So the total length of the plank, the beam, is 12 meter, correct? 12 meter, you divide by 2, so at the center is 6 meters, right? So it's somewhere here. Okay, if I label out, it's somewhere here. So the green one, this is 50 Newton, okay? And here is 1 meter, right? 1 meter, 3 meter, and this is 2 meter. Okay, 2 meter, and then here is 3 meter, and here is 3 meter. So this 2 and 3 meters is like together is 5, like this one, 5. Okay, so you have to know where is the force acting. First, you have to know that where is it acting. Okay, so at the center here. Now, after I label all the forces, now I calculate. Since this object is balanced, right? It's balanced. Okay, so all the anti-clockwise moment is the same as the clockwise moment. So let's find out what is the anti-clockwise moment. Now, when you calculate moment, you have to pick a point. Okay, for example, I say moment about point A. Okay, let's say your point A is here. Point A 在这里，这个凸体这边。Let's say that, okay, it can be anywhere. Okay, so you have to pick a point to calculate the moment. Meaning that the point that you pick, you are assuming that point is a fixed point. 就很像刚刚我跟你讲的那个 pivot. Okay, the point that you pick, you are assuming that is a fixed point. Okay, so you are calculating the moment based on that fixed point. Okay, now, so in this example, let's pick A. So A, moment about point A. So this one, right? 2T1, right? 2T1. 所以我们现在是找着 moment about this fixed point. So 2T1, this force is acting on point A exactly at the same location, correct? Now, what did I say just now? Force acting on the fixed point does not create moment, right? So we don't have to look at 2T. We don't have to look at 2T first. This one just cancel. Okay, we don't have to look at 2T. So we look at other forces. Now you have to identify which forces create the clockwise moment and which forces create the anti-clockwise moment. Okay, so this one 25 is creating the anti-clockwise, right? Because it's pushing down from here and then your fixed point is at A. So 25 is a anti-clockwise moment. 15 is a clockwise moment because it is at the right side of the point A. So clockwise moment 15, 50 also clockwise moment, and 30 also clockwise moment. And this 3t square, 3t2 is the anti-clockwise moment. Okay, and 20 finally is the clockwise moment. Now, so you take MA equals to MC. Now, how do we calculate M, the moment? Moment formula is M equals to force times distance, meaning that the force acting at that point times the distance from the pivot, from the fixed point. Okay, so MA, okay, let's do the 25 first. This one, the first one. Okay, so MA 25 Newton, right? So 25, we times the distance from the point A times 1. It's 1 meter from point A, correct? Okay, so 25 times 1 plus, we plus another anti-clockwise moment, which is the 3t2, right? 3t2. So 3t2 times the distance from point A, so it's 8. 3加2加3, so 8 here, right? Now equal to the clockwise moment. So you take all the forces like 15 times 3 meter from the point A plus 50, the weight of the beam, times 5, and then you plus what else? 30 times 8, and finally the last force is 20, right? 20 times 11. 20 times 11. Okay, and then you simplify. So simplify, and then you will get, I just straight away I simplify, okay? Until here, at the end, you will get like 24t squared equals to 730. Okay, 24t squared equals to 730. Then you can find t squared. Sorry, 不是 t squared, t2. Okay, t2. So t2 equals to 730 divided by 24. You get 30.42 Newton. Okay, so T2 is 30.42 Newton. Right? So how do you find T1? After you got T2. After you get T2, then you can straight away use the equilibrium of forces to find T1. What do I mean? For example, this one. T2 我写在这边啊。Okay, let's see. So the total upward force 就是 2t1 加 3t2 就是等于 the total downward force. Okay, 所以等于25加15加50. Don't forget the weight of the beam. Okay, if you forget the weight of the beam, then you got the wrong answer. So plus 30, also acting down, all the downward forces, you plus all. So equals to upward forces. Now, since you already know T2, right? You already know T2, then you can find T1. That's it. Okay, so you substitute your answer of T2 into this equation, then you are able to find the T1. Okay, so you have to use the principle of moment to help you to find this one because you have two unknowns, right? And if you didn't use the moment, then you only have one equation but two unknowns, then you can find. Okay, so any question, please let me know. If no question, you can write this down. Okay, you can write this down. Sorry, it's a little bit messy. Okay, still can see, right? So, So the final answer for T1 is 24.375 Newton. Okay, done. So if you haven't done, you can screenshot this one. But I also got record the session. Then later I'll post the link again. Okay, now maybe you ask, when calculating the moment, right? Just now I picked point A, right? Point A is here. This is point A. Now let's say this is point B. Now maybe some of you ask, okay, why you pick point A? Can you pick another point and show us the example? Okay, sure, can, no problem. Now, when you calculate moment, remember it's up to you to pick which point. Okay, so let's calculate moment about point B, just to show you example. Okay, just to show you the example, if I choose point B, so moment about point B is over here, right? This one 3T2, right? This location. Now, so when calculating here, I'm assuming point B is a pivot, right? Point B is the pivot, is the fixed point, and then I find all the other moments. Now 3T2 is acting at point B, so we don't look at it. Any forces acting on the pivot that you choose has no moment. Okay, now 30N also acting at point B, right? So we don't look at 30N. Okay, so how many forces we have? We have this one, 20, 15, 2T1, and 25, plus the weight, 50, right? So you have like 5 forces. Now you have to identify all the forces, which one is creating the MA, and which one is creating the MC. Okay, now I label out here, this one is MC, obviously, because it is at the right side of the pivot, right? MC, and this one is MC. 50 is MA, anti-clockwise. This one is also MA, and this one is also anti-clockwise. So 3 anti-clockwise forces and 2 clockwise. Okay, so MA equals to MC. Now MA 1 by 1, okay, 25 first, 25 Newton times the distance from the pivot. Okay, 所以是5加3加1，所以是9 meter. Right? Remember the formula, moment equals to force times distance from the pivot. And the force and the distance is perpendicular. Okay, is perpendicular. Is 90 degrees to each other. So plus the second force is 15 times 5. And then you plus the weight is 50 times is 3 cm, right? 3 cm. We just now we label here is 2 m, and here is 3 meter. Okay, and then 3 forces MA, so equals to 2T1 times 8 meter plus 20 Newton times 3 meter. Okay, so from this equation now you can find T1 is how much? It's the same, you will get the same answer. Okay, then you substitute to find T2 again. So it's up to where you choose the point. Of course, you have to choose. Now, why I choose point A and point B? Because when I choose point B, like here, in this case, in this example, meaning that I don't have to look at the 3T2 again. I can just cancel out. I cancel out one unknown. So only left one unknown for me to find it. All right, I choose A so that I can cancel out T1, so I can find T2. I cancel out one unknown, either one, right? Of course, you don't go and choose. You don't go and choose like here, point D. Let's say this is point D, okay? Moment about point D. If you choose moment about point D, what happens is you will get 2 unknowns because you have 3T2 and then you have 2T1. How are you going to find it? Right. Okay, so to make your life easier, you pick the point that is you can cancel out the unknown. Okay, so either here, B, or here, A. Okay, of course you can choose D. You can choose D. You just have to do longer step. Okay, you can choose any point as long as the system is balanced. Okay, so in chapter 2, right, we learn about for a balanced system, all forces is balanced, right? That is just the first point. The second point is you have to know also for a balanced system, the moments are balanced. Okay, clockwise and anti-clockwise movement. Okay, next is we look at this one. I talk a little bit about this one. Okay, question number 5 is about energy. Energy, kinetic energy and potential energy. Now, 5A, okay, state the principle conservation of energy. Okay, this one no need lah. This one theory, right? Energy cannot be created or destroyed, right? So let's look at the calculation B. Now, this figure shows a metal sphere moving from A with a constant speed of 6 meters per second. Then it moves up a frictionless slope with the height of 1 meter. Calculate the speed at B if the energy loss due to friction is 5 joules. So you want to calculate when the ball is at this point here, B, what is the speed? Okay, so this is about energy. Now, when the ball is moving initially, it has the kinetic energy, right? So the total energy is the amount of kinetic energy the ball possesses initially. As it rises up, it loses energy because of friction, right? Due to friction, it loses 5 joules of energy based on the question given. And then at the same time, it loses energy. Also, some of the kinetic energy is being converted to potential energy, right? Because it's rising, So we use the equation here. The total energy, the total kinetic energy at point A, I write KEA, is equal to the total energy, which is the kinetic energy at B plus the potential energy at B, and we also have to plus the 5 joules of energy loss. Okay, so based on the conservation of energy, because we know that all energy has to be converted to other form, okay, no loss. Okay, so yeah, of course there's loss, but you have to equate it in the formula. Okay, so that's how we get this equation. Okay, then the rest is just you put in the formula. The rest is just put in the formula. So half of mVA square, right, equals to half of mVB square, and then you plus mGH. Okay, so this one you can find it in the solution that I sent you. It shows detailed calculation of that one. So I'm not going to go through each of them. Okay, so I just want to talk a little bit about the concept here. Okay, so when you calculate here, you can find the velocity at B, which is 3.32 meter per second. Okay, this is the velocity at B. Of course, it slows down. Okay, initially it is at 6 ms minus 1, so now it becomes 3.32. Okay, you can straight away find, because in here there's no unknown. The unknown is only VB, so you can calculate it. Okay, now so question B, question 2, B2. Question B2, the height of C from the ground if it becomes 1.5. Okay, meaning that when the ball moves until here, just about to fall here at the peak, the height, you want to find the height HC. So you see there's a small slope rising, right? The small slope rising, right? So meaning that the ball gains more potential energy because there is a slight increase in the height. Okay, so from B to C, point B to point C, we are considering this motion, this movement from point B to C. We take the loss in kinetic energy, loss. 一下我的 pen stuck 了一下。So K kinetic energy loss equals to potential energy gain, right, from B to C. So kinetic energy loss, how do you calculate the kinetic energy loss? You take the initial kinetic minus the final kinetic, because initial kinetic energy is greater than the final kinetic energy, right? So half mv square, and this is VB, the velocity at B, the initial one, minus half mc square. Okay, now you know MVC square. MVC square. Okay, so VC, you already know that. You're given VC 1.5, and VB, you also know that. So you can calculate this one. So equals to the potential energy gain is mgh. Right? So the only unknown here is the h, right? M, you know the mass, G, you know, VC, you know, VB, you know. So only unknown is h. So you are able to find the increase in height. So this h is the increase in height, the change of h. Okay, the increase of height. So when you put in the formula, you will get 0.44. 0.44 is the increase in height from point B to point C. Okay, so like this small increase. Okay, so to calculate HC, which is the height from the ground, then you take 0.44 plus the 1 meter. Okay, the 1 meter at point B. So 1.44 meter. That is the final answer. Okay. Okay, next one. Number 3, question 3. What is the time taken for the sphere to reach the floor again from C? Okay, this one we use the equation of motions. Okay, so this is vertical movement, right? Falling down, vertical movement. So we use the formula, what is it? S equals to UT plus half AT square. UT plus the equation of motion. Okay, so at this point here, at C, the velocity is 1.5, correct? 1.5. 1.5. So we put in the formula. Okay. Now, here the S is minus 1.44. Okay, why minus is because it falls down, right? It falls down. So you're taking the reference point at the peak. Okay, at the peak at point C, at HC, height C, that is the reference point. So going down the reference point, it will be a negative because this is displacement. S is displacement. So you're going in the negative direction. Negative 1.44 equals to the initial velocity just about to fall. Vertical is 0. Okay, we are taking the vertical velocity, not the horizontal velocity. Okay, so U is 0. U is 0 and then plus half. Acceleration is of course negative 9.8. Or I just use 10 lah. Negative 10. Okay, negative 10 and then t square. Okay, negative 10 t square. So this negative and negative will cancel out each other. So t, then you find t will be 0.54 seconds. So time taken for the sphere to reach the floor from point C. Okay, so last question is